Today, we are performing a double displacement reaction of sodium hydroxide and nickel chloride. We'll start by obtaining two 50 milliliter beakers from the container shelf. Then we'll add 15 milliliters of sodium hydroxide to one beaker, and 6 milliliters of nickel chloride to the other beaker. The beaker containing sodium hydroxide appears murky white in color, while the nickel chloride is a very bright green. Now we'll pour the sodium hydroxide into the nickel chloride. Immediately after this is done, a precipitate forms and sinks to the bottom of the beaker, and the color of the solution transitions from bright green to a light gray or a murky white. Both the formation of a precipitate and the color change tells us that a chemical reaction has occurred.
The reaction is classified as a double displacement reaction because the cations and anions of the initial compounds switch partners when combined to form two new compounds. Here's an example of a double displacement reaction. In this example, B is displaced by D to form the product AD, and D is displaced by B to form CB. Based on this, the balanced chemical equation for the reaction performed looks like this. The products formed were nickel hydroxide and sodium chloride, and in order to balance this equation, there needed to be 2 moles of sodium hydroxide and 2 moles of sodium chloride. When we look at the balanced chemical equation, it is clear that the precipitate formed was nickel hydroxide because this compound is insoluble according to solubility rules. We also know that sodium chloride is aqueous, so we know that there are sodium and chlorine ions floating around in the remaining solution.